So we all know that these days, storing your sensitive information in the cloud, even though it's very, very convenient, it also carries some risks. And we've seen a lot of cases in the news of, very high profile individuals having their account hacked and very sensitive stuff stolen and exposed, which is clearly not a good situation to be in. And basically, there are a few things you can do to kind of make your cloud storage much more secure, and one of them is using Boxcryptor. So Boxcryptor is a fantastic tool. I swear by it, and it basically what it does is it encrypts all your stuff before putting it on the cloud in Dropbox or whatever, and therefore anybody who hacks into your Dropbox or cloud account really has nothing they can do with that stuff that they find. It's all encrypted and it's complete gobbledygook. And so I just basically want to sort of go over what Boxcryptor does and also a little bit about how it works under the hood, because maybe it's just me, but when it comes to your sort of most precious information, I'd like to know exactly what's going on, so I just have that peace of mind. So hopefully this will be interesting. I'll try and keep it as short as possible, although I'll warn you in advance, some of the stuff is a little bit involved, but I'll try and keep it simple and accessible. I'm using GoodNotes for this, which is a great little note-taking app for iOS, and hopefully it's kind of colorful and reasonably sort of expressive in terms of the content. So let's jump in and see what Boxcryptor is all about. So first of all, there are a couple of concepts relating to encryption and general security that I want to discuss just to lay the foundations for talking about Boxcryptor. So the first one we're going to talk about is symmetric encryption. And in a nutshell, all symmetric encryption is saying we are going to use a key to lock something up in a secure way, and the same key is used to unlock it and retrieve the thing that we locked in the first place. So if we use the analogy of a precious piece of jewelry, and we're gonna lock this up in a treasure chest, and we can use a simple key, which most treasure chests work exactly like this. You lock it with one key and you unlock it with exactly the same key. So if that key falls into the wrong hands, then a bandit or whatever is going to come and they're going to be able to unlock that treasure chest and take your precious jewelry away. And there are three objects in this scene. There's a golden ring, which we've locked up in the treasure chest with a symmetric key, and that symmetric key is the same key to lock and unlock. So hopefully that's clear. Let's move on to asymmetric encryption, which is somewhat similar, but with one extra dimension. And all the extra dimension is that the key you use to lock the treasure chest is not the same key as the one that you use to unlock it. So in encryption, we talk about the public key being the key that we use to lock the treasure chest, and the private key being the key that we use to unlock the treasure chest. And clearly, it should be apparent somehow that the private key is really the one that we're going to be most concerned about protecting, because that's the one, if it gets into the wrong hands, they can unlock your resources and get hold of them. So in this scene, there are four objects. We have the golden ring, which is again locked inside the chest, but this time we have two keys, one public key to lock the treasure chest and one private key to unlock the treasure chest. So that's really symmetric, asymmetric. Let's go on to talk about how these relate to actual computer files. And actually, it's exactly the same concept. So basically, we have a precious text file here, something secret, could be a movie script or something like that. In the case of symmetric encryption, what happens with that file is that we use a symmetric key, which is typically a long sequence of sort of random characters, and we combine these two as inputs into some kind of special, magical mathematical formula, which outputs an encrypted file at the end, which basically to any observer who tries to look at it looks like complete junk, and it's indecipherable. The only way you can actually extract the original precious movie script out of that junk is, down the bottom here, is to apply the symmetric key through the unlocking or decryption formula, and then get your original script out of the other side. So again, because we're using symmetric encryption, what that means is that it's the same key that we use to lock the file as it is to unlock the file. And so we have the same three objects in the scene. We have our precious resource to lock up, we have the key, and we have the chest, which is basically represented by the locked file. And for asymmetric encryption, when it comes to computer files, we have the script that we lock up with the public key. So we're turning the public key in that chest to lock it up, i.e. using the encryption formula. That basically creates our secure locked file. And then to unlock it, we're going to use the private key, pass it through the decryption formula, and retrieve our original content. So we have four objects in the scene. We have the precious script, the public key, the private key, and the treasure chest that stores the actual secret content. So that's asymmetric and symmetric encryption. So basically, this should be reasonably intuitive, but if you store your contents in Dropbox without any form of encryption whatsoever, then effectively you are just taking them and you're dropping them in a box. Just think of it like a box, and the box is on a server somewhere, and they claim the box is secure, but once in a while your Dropbox account might get hacked. So somebody is going to come in, peer inside that box, and lo and behold, they're going to see your unadulterated raw content, and they can do whatever they want with that. They can copy it, they can view it, they can send it, they can delete it maybe. So your files are all exposed, and that's the situation that we definitely want to avoid here. So what's happening with Boxcryptor effectively is, instead of storing your actual raw files on your Dropbox server, you are storing lots of little mini locked treasure chests inside that box. And somebody peering into your Boxcryptor account because they've managed to sneak their way inside illegally is not going to see any of your actual precious script files or personal details. They're just going to see these encrypted files, which, unless they have the keys to unlock them, are going to be completely and utterly useless, which sounds much more promising to me. So the last concept I want to talk about is, in terms of the basics, the basic sort of more or less theoretical side is hashing. Hashing is really quite a simple process where you take a piece of information, and apologies to vegetarians, but I'm using the analogy of a mincer here. So we're going to take a piece of fillet steak, pass it through a hashing algorithm, and out the other side pops another piece of information called a hash, which, if you like, is a kind of a scrambled result of passing your original message through that algorithm. Okay. Now, the two key points about the relationship between the hash and the original message, the original piece of information, is you cannot go back from the hash to the password. Right, so we're talking about passwords here. So even if you have the hash, you can never know what the original password was, right? However, you're also guaranteed, when I say guaranteed, I mean it's sort of almost infinitesimally small probability that this would be violated. So you're almost guaranteed that no two passwords will actually come through this machine and produce exactly the same pattern of mints on the other side. So they're not going to produce the same hash, if you like, right? So yeah, it's a bit of a sort of long-winded concept, but it's just very key to know that basically when you log into Boxcryptor and you're authenticating yourself, they do not have access to your password, right? What they store on their database is the hash of the password. So, for example, if my account password is Ginger Rogers, then when I sign up for the account, that password is put through the hashing algorithm, and the corresponding hash generated, which is 1x23pqzlth, that is stored on the Boxcryptor server. So for when we authenticate ourselves in future. So if I then open my account and I log into Boxcryptor with the password Dr. Doolittle, then on my local device, okay, the Boxcryptor application is going to hash Dr. Doolittle and produce the output here, which is xq1v4hczh. It's going to send that hash to the Boxcryptor server, and in the Boxcryptor server is going to compare the hash that I sent with the hash that it has associated with my account. And given that these two are obviously not equal because I didn't type the right password, then Boxcryptor says, you're not getting in, you've entered the wrong password. So it's really important to note that Boxcryptor was able to tell us that we did not use the right password, even though Boxcryptor has no way whatsoever of knowing what your password is and never will know. So you cannot call up Boxcryptor and say, hey guys, I lost my password and I can't decrypt any of my files. Can you reset it for me or whatever? They do not have access to your password at all, right? So that's why they call themselves a zero knowledge service, which has its benefits and it has its drawbacks. The benefits is that even if somebody hacks the Boxcryptor server, gets all the information about your account, they cannot, even if they then hack your Dropbox, they do not have enough information to retrieve any of the files whatsoever. So that's very, very good. But with power comes responsibility. Your responsibility is that you and only you are responsible for the password. Your device and your memory are the only places anywhere that know that password, and that's crucial to the whole system. So just to sort of to reiterate the point about logging in. So here we are with a proper example. So we're at the login screen, and let's say my email address is hotpotato@gmail.com, and I enter the password Batman, and it goes through the hashing algorithm, generates this hash here, and then so this all happens on the iPad or the device, right? So the password itself in raw form never ever leaves the device. Only the hash is sent over the internet to the Boxcryptor server, which looks up in the database for hotpotato@gmail.com, retrieves the hash, and says, okay, do the hashes match? So has the hash that this guy sent me, does it equal the one that I have? And in this case, you can see clearly that these two are the same. So we have a success, and therefore that user is authenticated and can open the Boxcryptor application on his local device. Otherwise, he's not going to get to log into the application, and he can't browse any of the encrypted files on his device. Okay, so that's authentication and password hashing and all that kind of stuff. So hope you guys are still with me. We'll move on to the actual artifacts which are assigned to a user when you sign up for a Boxcryptor account. Apologies, I really need to make the distinction clear. When you sign up for a Boxcryptor account, you're going to get 4 things, right? You're going to get a username, which is obviously, in this case, it's your email address when you register. You're going to get a public key, you're going to get a private key, and you're going to get a password. Now, let's have a think about where these different pieces of information are stored. So the public key is stored on your device. Your private key is stored on your device. Your password is stored on your device if you choose to memorize it, just like with any application. It says, do you want to remember password? Otherwise, your password is just stored away in some part of your brain. But what is key is to think about what is being stored on the Boxcryptor server, right? So again, we think about the Boxcryptor server like a sort of a database table with one row for each user, and for this particular user, so we store the public key on the Boxcryptor database, right? The public key is not sensitive information. It's not secret information, because the public key, if we think back to our original treasure chest example, the public key is only used for locking things. It cannot unlock anything, right? So nobody can use the public key to unlock any of your secret resources. So for that reason, we store it in its raw format on the Boxcryptor server. And that's because if you want to add any other devices in future, then those devices can retrieve your public key from the Boxcryptor server when they install the application. Okay, so that's the public key. The private key, it's a little bit more intricate, but hopefully the treasure chest analogy will kind of help illustrate the point again. So basically, we do store the private key on the Boxcryptor server, but not in its raw format. The reason being that the private key is basically the most important piece of information. So if anybody gets hold of your private key, then they can unlock all of your files. If they get into your cloud provider with the private key, they can unlock everything. So we don't want anybody to be able to hack the Boxcryptor server and get hold of the private keys in raw form, right? So what we do is we lock the private key up in a treasure chest using the password as the key, right? And as with all the diagrams in this series, an amber key means a symmetric key. So it's the same key to lock and the same key to unlock. So we're putting the private key into a little treasure chest. We're going to lock it with the password, and then we're going to put the treasure chest on the Boxcryptor server. And that's what the Boxcryptor server stores with our private key, right? But the important point is that without the password to unlock it, we can never, ever retrieve the private key from the Boxcryptor server. So don't call the Boxcryptor support team and say, hey guys, can you send me my private key, please, because I've forgotten my password. Without your password, they will never be able to send you the private key, which is, again, it's really good for security, but it puts a lot of pressure on you to make sure you remember your password. Now, the last thing that Boxcryptor store on their server is the hash of your password. And we've already seen that from the previous two slides. That is purely for authentication. So for example, when you send the password you've entered when you log in, it goes to the Boxcryptor server, and then the password hash is there, and that's purely for authentication. And again, Boxcryptor do not have your password in raw format and never will. So that's it's just purely for authentication. Right, so moving on to a little bit more about just how the Boxcryptor app looks and works on your iOS device. So it's really, think of it, the Boxcryptor as a kind of another layer on top of your Dropbox. So when you first log into the Boxcryptor app on your phone, this is taken from my iPad, but it also works for Android and iPhone too as well. So basically, Boxcryptor asks you to select which cloud provider you want to connect to. I choose Dropbox, and then you can browse the directory structure of your Dropbox account. So we can see here that all of the files have a green color, and what that green color means is that this particular file is encrypted with Boxcryptor. And notice the file extensions, as viewed through the Boxcryptor interface, are ending in .pdf. That's because these were originally files saved in the PDF format. Okay, but these are encrypted because they are showing up in green through the Boxcryptor interface. Now, to illustrate that point, if I then this point 3 is taken, I'm actually browsing the same Dropbox folder, but through the native Dropbox application, and we see that the files, they don't show up in green, but because that's specific to Boxcryptor. But more specifically, the file endings are ending in .bc, so they're not ending in PDF. There's a BC appended to the file extension. So what that means is that if I'm somebody peering inside Dropbox, and I want to look at this document, dummydiary.pdf.bc, this is not a PDF file. This is a Boxcryptor file, and it's completely unintelligible to any other application other than Boxcryptor. So unless I'm viewing this through a Boxcryptor interface, an application either can be on iOS, or it can be Boxcryptor for Windows or Mac or whatever, I'm not going to be able to view the actual unencrypted contents of this file. So that's really how the interface looks. So let's talk about what is represented by this dummydiary.pdf.bc file that we saw here. So in the next slide, I've illustrated it as think of it like two treasure chests sitting side by side, and that's all, and grouped together, represented by this .bc file. So one of the treasure chests has a symmetric lock, which is the one on the left, and that one contains our actual document, the raw contents of the document we're trying to protect. So that's inside that treasure chest there. The other treasure chest, which is an asymmetric treasure chest, meaning we lock it with one key and unlock with a different key, that contains the key to open the first treasure chest. So it's quite straightforward, really, the concept. So given that what I want to do is to unlock and view the raw contents of my document, how does this actually happen in the background? And I do want to stress that all of this is kind of stuff that Boxcryptor does automatically behind the scenes. This is not, these are not manual steps that you have to do in any kind of workflow. This happens automatically when you open a file through the Boxcryptor interface. So, for example, in the previous slide, if I were to just click on that file there through the Boxcryptor application, the PDF would open up in my PDF browser. So what's happening here is just an illustration of what Boxcryptor is doing behind the scenes when that happens. Okay, so back to our so how do we actually unlock this file, or how does Boxcryptor unlock it? Well, it all starts with the private key. So we've mentioned many times already, the private key is the thing that we're going to use to unlock our files, right? So we take the private key, and we can see that if we pop it in this lock of the second treasure chest, right, the box opens up and out pops the file key. Now, the file key is basically the key that is used to unlock the first box, and the first box contains our original text that we want to view. So we take our file key that comes out of the first box and pop that into the lock of the second box, and it opens up, and then, this is the symmetric box, by the way, same key to lock, same key to unlock, that opens up and out pops the original content that we wanted to protect. Okay, the file key itself, this one here, is basically every file that gets stored inside Boxcryptor has its own file key associated with it, and the file key is encrypted inside this box here, and it's typically a fairly small sequence of numbers or characters. Okay, so yes, so basically, just to sort of reiterate that point, we have our dummydiary.pdf.bc file here. So the top part of the file, if you like, is the encrypted file key, which is the file, the key that unlocks the first box. So the file key, which is required to encrypt and decrypt the contents using the user dedicated public key. So the file key can only be decrypted using the user dedicated private key. That's fine. So then I just want to go over this point in case you're wondering, why not just take the entire file contents and encrypt them using the user's public key and then decrypt them using the user's private key? So effectively, why use two treasure chests here when you could just put the actual document in this one? And the reason is that even though it's more secure, the private public key encryption is actually computationally more time consuming and more expensive. So actually, there's an error down here, which is that should be asymmetric, just in case you were paying attention. So basically, if you take a huge file like a massive PDF, or you can encrypt any files in Boxcryptor. To encrypt the entire contents of that file using the public key and decrypt it using the private key is very time consuming, right? So instead, what you do is you use symmetric encryption to put the file in its raw format in this box here, which is very quick, right? And then you take the key that you need to unlock this box and you encrypt that by putting it in a public-private key box, which is very, very secure, but doesn't take very long to encrypt the file key. So that's a bit of a sort of an aside for those of you who were curious about it. But don't worry about it too much if it's not 100% clear. So when I create a new account, or let's say a new instance of Boxcryptor on another device, how do we get the keys actually onto the devices? Because we know what's stored in the actual Boxcryptor database, right? We have the public key, we have the encrypted private key, and we have the password hash. Okay, so if I want to install Boxcryptor on a new device, how do I get hold of my keys? Because it's all my data, my sensitive data, is stored out there in the cloud in Dropbox, but it's been locked with this public key, and I need the specific private key to unlock it, right? So I'm going to need a copy of those public keys and private keys to actually use Boxcryptor on my new device. So let's say I installed Boxcryptor initially and set the whole thing up on my iPad, and now I'm installing it on my iPhone, right? So how do I get the keys on my iPhone? First of all, I'm going to install Boxcryptor on my new device, which is very straightforward. And then you're going to sign in with your email and password. And remember, when we authenticate in Dropbox, all that's going to happen is that the hashed password is going to be sent to the Boxcryptor server, and then the Boxcryptor server is going to say, yes, you are who you say you are, or if you enter the wrong password, it's going to throw you out. Okay. Now, when you log in successfully, Boxcryptor sends two things back to your new device, your iPhone in this case. It's going to send your public key, because remember, the public key is stored in unencrypted format in the Boxcryptor server because it's not secret. And then it also sends your encrypted private key back to your device. And now, the public key, as I mentioned, is not secret. The private key is encrypted, as we saw before, using the user's password. But because obviously the user who's setting up the account knows the password, then they store that information on the device, and that password is used to decrypt the private key. So now we have the private key and the public key all set up and secure on the new device, i.e. the iPhone in this case. So the last thing I want to talk about is a kind of an extension to this, which is called a local account. So what's a local account? Well, a local account effectively takes out the need ever to communicate with the Boxcryptor server ever again. Now, the reason why I say this is cool is because I'm a big believer in sort of buying a product or installing a product and not relying on the sort of day-to-day operations of the provider of that service to actually get your job done. So when I say, for example, let's say you use Evernote for text searching, because when you write something in Evernote and do a text to a writing to text operation, it has to go back to the Evernote servers and come back. And this and also you have to pay a subscription every month. I don't like this model. I think that if you pay for some software, you should get it, install it on your own device, and you should be sufficient from then on, so that even if the Boxcryptor website or servers go down or even get destroyed, you can still install Boxcryptor on new devices and use it in your day-to-day business. So basically, to set up a local account, you just go to the Boxcryptor website, and then you go to the bit that says export your key file. Then you just have to save that key file somewhere. The key file ends in a .bc key extension, and you can save this key file anywhere you want. And so one of the sort of key concepts in this video is to sort out which files, which bits of information are secret, i.e. at all costs must be kept from anybody, and which pieces of information are public and not secret. And this .bc key file is an example of something that's not secret, because it's completely useless without your Boxcryptor password. So you can save it right there in your Dropbox home folder, so you can access it on any device that you want to set up Boxcryptor on, and it's perfectly fine. As long as you don't share your password, nobody else can abuse this file, right? So on your device, you basically just go to the login screen and select the local account option. Then you browse to your .bc key file through your Dropbox application or wherever else you have that file stored. It could be in an email attachment or whatever. Then you should see that from this point on, your Boxcryptor local installation is wedded to that particular BC key file, right? And then you just enter your email password as usual to log into the application, and you're up and running. So what does this BC key file actually do? Well, as we sort of hinted before, the BC key file is taking the place of the Boxcryptor server, right? It's taking that out of play altogether. So it's quite easy to envision what's going to be in it then. So obviously we're going to be using the BC key file to authenticate ourselves. So obviously it's going to need to store the email and the hashed password. It's going to store the public key, and it's going to install the symmetrically encrypted private key, right? And that's why the BC key file is not secret, because if anybody gets a hold of this file, they can't get your private key, because just like on the Boxcryptor server, the private key is encrypted using the user's password. So that's why this file is not a secret file. Okay, so if you think about it, the information in this file is exactly the same information that's stored in the Boxcryptor user database. So as I said, this is just all about saying, listen, Boxcryptor, I don't need your servers or your database or your authentication. I'm going to do it all myself locally on my new device. And if I want to install a new device, then all I need to do is make sure that I keep hold of this BC key file, and then export that or install that BC key file on the new device. And from then on, every time I log into Boxcryptor on that device, I'm going to be authenticating with the hash password inside that file. I'm going to be using the encrypted private key to install the unencrypted private key on my new device using my password, and it all happens offline. So I'm a big fan of this, and I think I would always try and sort of take out the dependency on a network connection to authenticate and and log into any application and use it where that's possible. So that's the end of the video. I hope some of you managed to follow it all the way through. I know it's a bit hairy in places. Any questions or feedback, please leave them down below in the comments section, and I promise I will get back to you with a hopefully coherent response in the near future. And also please subscribe to my channel. if you're interested in seeing some other tutorials in the similar kind of format on the same kind of topics in the overall kind of security and personal organization type field, and maybe beyond. But thanks for watching, and see you in the next one.